I want you to find every angle between 0 and 360 where sine of theta would be negative radical 3 over 2. Alright, so yesterday we were seeing problems where I would give you the angle and you had to find what sine was equal to. We're working backwards, we're finding that angle now. But we can kind of start in the same place. We can do our quadrants and our reference angles, just like we were doing yesterday. Quadrants. If we think about all students take calculus. Okay, every trig function is positive twice and negative twice. Sine is positive in which quadrants? 1 and 2. So that means since it's a negative, I will have an answer for quadrant 3 and quadrant 4. So I'm going to get 2 answers out. Sine would be negative radical 3 over 2 twice. Reference angle. I need to know when sine is square root of 3 over 2. So if we think about our hand trick, sine of 0 is 0. Sine of 30 is 1/2. Sine of 45 is radical 2 over 2. Sine of 60 is radical 3 over 2. So my reference angle is 60. Right, now we just need to figure out what these actual angles are. If I'm in quadrant 3 and this reference angle is 60, can you tell me what the whole angle would be? From here to here is 180 plus another 60 would be 240. So the sine of 240 degrees is negative radical 3 over 2. Or if I were in quadrant 4 and my reference angle is 60, then the actual angle from here to there, we would have to do 360 minus 60 and we would get 300. So the 2 times sine is going to equal negative radical 3 over 2 are at 240 degrees and 300 degrees. Does that make sense? So we're just finding the unknown angle. So B, secant of theta equals 1/2. Now we're probably not as familiar with secant, cosecant, and cotangent. So the first thing I'm going to do is rewrite this. Secant is the reciprocal of what? So this means cosine is the reciprocal of 1/2 is 2. Okay, quadrants. And what quadrants is sine or is cosine positive? 1 and 4. So I'm going to have an answer for quadrant 1 and 4. Reference angle. When is cosine equal to 2? Can it equal 2? Remember back in chapter 1 we talked about the possible values for our trig functions? And we said that sine and cosine have to be things between negative 1 and positive 1. So is it possible for cosine to equal 2? No. So this one is no solution. It will never happen. Let's do one more. If I said tangent of theta is negative radical 3 over 3. Quadrants. When is tangent negative? 2 and 4. tangent radical 3 over 3. Think about your hand trick. Tangent of 0. Square root of 0 is square root of 4 is 0. Tangent of 30. Radical 1 over radical 3 is radical 3 over 3. So that's 30 degrees. Okay, so if I'm in quadrant 2, and my reference angle is 30 degrees, the actual angle would be 180 minus 30, or 150 degrees. I'm in quadrant 4, and this is 30 degrees. Then the actual angle would be 360 minus 30, or 330 degrees. Any questions there? Do you want to work on this homework, or you want me to go ahead and teach 2.3 first? Is that a preference? I'm just going to go ahead and teach 2.3. Not every angle is one of those nice angles on our hand. 0, 30, 45, 60, and 90. Those are the only ones that we just have to know the values for. The rest of them we are using our calculator to get. So I just want to take a little time and make sure everyone knows how to use the calculator to get these things. So when we are on our calculators, we need to be careful. There are actually 2 different modes on our calculators, degrees and radians. We have not learned radians yet, so right now we are in degrees. If you're using one of these, to check your mode, there's a mode button right by that second. And you can see right now mine is in radian mode. So the very first thing I need to do is flip it over into degrees. Now if you're using your own calculator, once you change that setting, it'll stay unless you reset the memory. But if you're using one of mine, they get changed back and forth a lot, so you want to make sure that you flip it. So we need to make sure, first of all, that we are in degree mode. Okay, so I can get out of here. Second thing, we have sine, cosine, and tangent buttons. This sine -1, cosine -1, tangent -1, it's not what you think. It is not a reciprocal. So normally we see a -1 power and we're thinking reciprocals. That is actually the inverse notation. Remember in college algebra we did find inverses. That's what that represents. So if you want cosecant, you have to do that as 1 divided by the value of sine. You can't use that -1 button. Alright, so now we're just going to practice and make sure we can get these. Sometimes we have degrees and minutes, we might see those. There is a way to put it in degrees and minutes in your calculator, but it's really annoying to get to and takes a little bit of time. So the easiest option, if I did give you degrees and minutes, when you push that tangent button, it will automatically open a parenthesis. So every time you push a trig function, it opens a parenthesis. If I want to do 68 degrees and 43 minutes, when we change minutes into decimal form, what do we do to it? So I'm just, in my parentheses, going to type 68 plus 43 divided by 60. So tangent, 68 plus 43 over 60. And if I type that, I get a value of 2.567, how many decimals? Let's say 5671. Okay, that is not degrees because we weren't finding an angle. That's just what the ratio of tangent is equal to. If you took that angle and you did opposite divided by adjacent, you would get that number. Alright, you guys tried cosine of 193.622 degrees. Let's see if we get the same thing. Negative 0.9719. Did you guys both get that? Okay. If I want to type in cosecant, cosecant is the same thing as the reciprocal of sine. So I have to type it in as 1 divided by the sine. 35.847. Negative 1.7076. Okay, secant. How would I type in secant? Divided by cosine. Now this one we have to be careful. My angle is negative 23 degrees 27 minutes. But if I type it in like this, I'm actually going to get the wrong answer. Okay, I put the negative on my 23, but technically this entire angle is negative. So if you had degrees in minutes, you would have to do your negative degree in the negative minutes if you're typing it in. So it's just kind of a weird quirk. If you have a negative with degrees in minutes, you want to subtract off your minutes. And you get 1.0900. Any questions about how I'm putting those in? And we can only do this if it's not one of those common angles. So, you know, if it is radical 3/2 and you give me the decimal, I'm going to count it wrong because I want exact values if it's 30, 45, 60, 90. But if it's not, we will use our calculator. All right. The buttons on there for the inverses are what we use if we are trying to find the angle. So if I'm asking you to find the angle between 0 and 90 degrees that satisfies this condition, cosine of theta is 0.9211854,056. We are trying to find our angle. Cosine is attached to that angle. The only way you can move the cosine is to do the inverse of it. So to move cosine to the other side, it becomes cosine inverse. And later on, we will talk more about what an inverse of a trig function means. But for now, what you need to know is that -1 is finding the angle. It's working backwards to find our angle. And so if I want this one, I'm going to type it in as cosine inverse. So I'll have to do second cosine because I want the angle. 22.9. This time that is the angle, so that is in degrees. And we could check it if we did cosine of 22.9 degrees. We do get the same decimal back. All right. B has an extra little trick to it. When I look at this, if I just wanted to find my angle, to move my cotangent over becomes cotangent inverse. But do we have a cotangent inverse button on the calculator? No. So before I do anything, I'm going to rewrite this. Tangent and cotangent are reciprocals. That means tangent is 1 divided by this. And I'm just rewriting it as tangent because we don't have a cotangent inverse button on the calculator. So now to find my angle, to move my tangent over its tangent inverse of 1 over 1.446647. You guys check, make sure you can get it when you plug it in. I got 34.6543 degrees. Do you guys have any questions for me on how to put these in the calculator? That's really all I have in this section. So you guys all have the problems written down from yesterday, right? We've got a lot of time right now. This one I just have a few more problems that we're going to do. And